Okay. Okay, thank you. Dear ladies and gentlemen, let me introduce my paper titled The Limitations of the Optical FBMC Multi-Beam Transmission in Optical Fiber Communications. So this paper is from the area of optical communication networks and systems. The trend of future fixed 5G networks is heading toward high numbers of customers, larger area coverage, and higher bandwidth per unit. For this aim, novel approaches and designs of modulation formats are expected in the next generation of passive optical networks. The filter bank multi-carrier technology is considered for solving these problems due to the low bandwidth efficiency of subcarriers limited by the on-off keying and presents a possibility for reaching higher spectral efficiency. Many works, as introduced in the paper, are oriented on its successful implementation from various aspects. And in this paper, in this contribution, a new optical multi-beam transmission in the optical fiber environment by using two modulations is proposed. The basis for our performance analysis is the OFC simulation platform for optical fiber communications that we realized. This platform is consisting from three parts. The core is the red block. Yes, the single mode fiber environment that models negative influences of the fixed optical environment, above all chromatic dispersion and polarization mode dispersions. The new modulation format is must be implemented in transmitter and receiver parts of the optical transmission path. And after the incorporation, the FBMC modulation format, higher efficiency of the transmission capacity can be achieved. From the theoretical background selection, some information, the FBMC transmitter converts a binary data stream into complex symbols in sequent steps. And one from these steps is the OQM block. It means orthogonally quadrature amplitude modulation block. It means that an output binary data stream can be divided into multiple tributary subcarriers on the transmitter side in this block. And the data separation is realized by utilizing the OQAM property and 4 QAM quadrants that are based on value and phase of the complex symbols. Practically, we must adapt the OFC simulation platform in 3 parts. As you can see, here are the detailed block schemes of FBMC transmitter and receivers. The output of the FBMC transmitter are 4 transmission channels on different wavelengths. And of course, on the receiver side, there are 4 transmission channel, 4 signals from these channels received. Basic parameters for these modulations are presented here. What is important, also simulation parameters for the transmission channels are detailed described in the table. So, numerical simulations of our performance analysis are divided into 3 parts. In the first part, for the data separation, we can see bit error rate levels at the optical FBMC multi-beam signal transmission utilizing data separation in the first table for various multi-state QAM modulation and for various transmission distances. As we can see, for some cases, the signal or signals are not correctly detected and cannot be processed. Then we compare these results with our previous performance analysis of the optical FBMC single bit transmission. And in the figure, the comparison from the viewpoint of Q factor, it means quality factor. The higher value of this Q factor, the better transmission. And as we can see, optical FBMC multi-beam transmission has worse Q factor values, and the reason for these values is in the environment of the optical fiber, and specifically in the effect of four-wave mixing of its negative effect. This environmental influence is closely related with the channel spacing. It means differences between wavelengths of transmission channels. Therefore, in the last part of our numerical simulations, we analyzed the influence of the channel spacing adjustment. And as you can see, based on bit error rate levels, after the channel spacing adjustment, for given multi-state QM modulation at the given this transmission distance, better values of the bit error rates are present for the coarse channel spacing. So a summary of our FBMC numerical simulation can be presented as follows. A transmitted optical signal is not possible to evaluate for some combination of path, lengths, and modulation states due to environmental influences. The optical FBMC multi-beam transmission utilizing data separation at the 0.4 nanometer channel spacing has lower values of the Q factor due to a significant four-way mixing effect influence. Moreover, increasing the number of internal QAM modulation states in a single beam signal transmission leads to a significant bit error rate increment. However, the optical FBMC single beam transmission is better and still preferable. The main negative influence of the optical fiber environment for this type of the signal transmission, I mean optical FBMC multi-beam signal transmission, will be represented by the four-way mixing effect. It means that the coarse channel spacing is more suitable than the dense. Conclusions of this contribution are presented as follows. The optical FBMC multi-beam transmission is strongly dependent on the coverage of geographical areas and on the channel spacing between adjacent wavelengths. The optical FBMC's multi-beam transmission applying a selected data separation technique can be effectively incorporated into optical fiber communications only after the elimination of the four-way mixing and cross-phase mixing influences. And finally, the optical FBMC multi-beam system with the coarse channel spacing can be appropriate and useful for utilization in small geographical areas. Finally, I'd like to present information about the acknowledgement. This work is created with the support of the KEGA agency project, and last, my contacts. Thank you for your attention. Yes, question?
Any questions?
Standard for the optical environment. Uh, there are various standards for optical fibers, depending for the utilization of these optical fibers, and specifically this, in this case, it is standard, I think, ITU-T G657. The newest standards for optical fibers that will be used in optical communications. In previous simulation platform, there was standard G or G.652. So in the simulation platform, there is no problem to change the parameters of the optical fibers. The parameters of the optical fibers are presented in this table, and these parameters are from standards, can be changed for other types of the simulation. There is no problem, and are confirmed by measurement in our institute if necessary. Uh, in the simulation platform, there are two types of evaluation of received signal. The first type is the constellation diagram. The second type is eye diagram. And it is not present in the paper because it's basic, and I don't repeat it in the paper. But if you, for the evaluation of optical signal, received optical signals, the eye diagram is used. And the opening the eye is closely related to the bit error rate values. So if we receive the good signals, eye is opened, then it means the bit error rates are low. And in otherwise, if yes, always close eyes. Uh, then yes, results of this performance analysis were able after correcting and realizing all necessary parameters of the environment here, and also in the transmitter and receiver parts. It means if everything is bad in the simulation, that the signals are not correct. And it is maybe in this situation, the signals are not correctly received. It means we must manage blocks and parameters in the blocks, and everything is necessary to receive correct signal. Oof.
I think maybe we can follow up discuss more and then move on to the next speaker because we only have to leave it time for discussion. Is that okay with you? You can
Yes. We will discuss later after this contribution. Okay, thank you.
Thank you very much.